Hi, it's the Maker's Corner again. Oh, it's been a kind of a hectic day today. But anyway, we're back into business. I'm gonna have to eat something at the same time because I haven't had any dinner because there's been so much going on. So I'm sorry for this. It's also very unhealthy. So, Friday, unhealthy food, tech, what can be better? So, let's see, yeah, made some improvements to the Python side, to the client side of things. So I've been adding database functionality. Let's see now, I just have to look at my notes. So I've been using the exe-files database, the one that comes with Python, so one doesn't have to sort of do any extra installation work. Am I hungry? I'm so sorry. So anyway, because it's packaged already with the base Python, you don't need to install any extra modules for it. So then you can just declare it. So you import SQLite and then the error handling related to it. So nothing that magical. You can find instructions online. Just search in Google. And then this is actually cool because this creates I probably can't. Oh wait, I've got the wrong. Why is it doing? Oh, why is it? Oh, looks like it's messed up this view again. Why is it doing this? Desktop not available, it says. Why? What? Why would the desktop not be available? This is what, XSplit bothers me a bit because, you set up all this stuff and you even save the whole setup. And then sometimes when you come back, it's just like something's vanished. It's like the camera's gone missing, or now in this case for the very first time, the desktop is missing. So, no, that's the wrong desktop. I don't want that one. Well, anyway, we can learn about Xtop at the same time. So I really don't understand why it does this. I'm gonna have to save my presentation. Sorry about this. It's like when one thinks it's always worked, so now it should work stable. It's like, oh no, something new pops up. Okay, now we're kind of back in business. I have to bring up my notes again. I don't know. Maybe I should move over to OSB or like some other. What was it called? Oh, there are other softwares available. Oh, I think it's called OBS. Well, anyway, now you can see this display. So what I was trying to show was But it's very easy just to declare the SQLite. So you just import that stuff, and then you get the full functionality. Well, unhealthy food can really taste good when you're hungry. Yeah. And then I was showing that it actually creates, I'll bring it to the right display here. It actually creates a file, which is the database file. Well, that's good, so you can create one or many databases. It's not like if you have a database engine, then it basically stores it in an internal set of data files, and you can't really say, okay, give me this specific database. You can sort of go in and extract the data from a specific database defined in the virtual database structure. But this is by far the easiest, because if I want to keep this data, if I want to keep the data in this database, or I want to create multiple copies, or I can put the databases in different physical files, and then I can take backups, or time backups of them. There are some drawbacks. This is like SQLite is for basically a single user, single process access, so you probably wouldn't use it for a web server. Or a multi-user system. Anyway, moving on. So what I did is I added some code here, so when I start the UI the first time, then it will actually check if the database actually exists. So my file is I have given it a name, and then it just checks if it exists, and if it doesn't, then it actually creates the database, including the table that's needed. And this is great because you programmatically create both the database file and the data structure in the database, which is the table you need to store the data. So it's quite dynamic. And no, I'm not drinking alcohol on this channel. I just define one simple table, created a connection to a database with the database file name, and it automatically creates the database file if it doesn't already exist. And then it just using the connection, if it succeeded in opening it, issues this basically an SQL create statement and creates the database. And you can copy paste these routines from the net. There are several support routines that are actually not included in the actual base module you get, so you actually have to can actually just show this as an example. So in the education material for SQLite, then you find these examples of, for example, create table routine. So basically it executes a command to execute the SQL that I've just given. And if you're not familiar with the SQL language, which in itself is a story of its own, then you can search Google and stuff. So basically SQLite, as far as I can see, it needs that you work against it with pure SQL. So it doesn't have functions and stuff for many operations. You want to create a table or insert data or query data, then you need to have. Okay, so now that's done. So I've created the database file with the database table entry, And now every time it gets an experiment message from the Arduino, then it I did add some logic to delete the old, if it's if you run the experiment like twice, then it will delete the data from the previous run for that specific experiment. And there was a hook or a problem. Well, problems are meant to be solved. Let's see now. I can find it. I think I actually have it down here. And then when I went into sorry, a bit tired. Where did I put that? Oh, this is a bit dumb. Ah! I'll put it up here. Oh, I need to close that. Fine. So when I execute a specific experiment, then it says, okay, delete the old data, and then it passes the experiment name. And this was interesting. I actually moved back to the idle editor. I had to quit using the mu editor because it the tracebacks it gives on runtime exception. When a runtime exception occurs, it doesn't display all rows of the exception, so it's really hard to know where it crashed. And then plus the issue in debug mode, it was crashing on internal failures in modules, which doesn't happen in idle. I can run the same code in idle with that exception and get a full, like it won't actually fail, but in mu it does. And that's setting up the debug session. But anyway, I don't want to go into that detail, so I gave up with mu. I think it's still too experimental to be for practical use, so I went back to my reference platform, which is idle. Anyway, this was interesting because when one issues this basically, for anybody who's worked with SQL, it's very easy. You say delete measurements is my table, and then I say okay, and then the experiment parameter here gets replaced with the experiment name, and then it basically executes it. Now, at the beginning, I only had this code, and this is from the example that I found in the training material for SQLite, in several different places on the net. So not only one training material. And then I found a helpful guide. Oh, well, they pretend to be helpful because what they say, well, of course you should do this. Don't you know? No, we don't. So anyway, it was written in that kind of a style. Newbie, fix it. But you actually now have to issue a commit statement. And this is very typical for interaction with SQL database type systems, that you can queue SQL commands like change this, move this, and then you can say at the end, you can say, okay, now commit it to the database. Now, what made this really confusing is that this is half committed when you execute the delete and you query the database. Or what I did is I did because it wasn't deleting the records. So what I did, I built a separate test program. I can actually show that. I wonder if I still have it loaded. Oops. Wrong file. I wonder if I still have it loaded here. This one here. So anyway, it's got some those utility functions. So anyway, what I did is that, okay, in my original code I didn't have this commit statement. So basically I said like select all measurements, and basically what this does is that it prints out all the rows in the table. And then I said, okay, delete it with the typical example without the commit. And then I said, okay, print out all the measurements. And this showed, this line here, showed that the measurements had gone. It didn't retrieve anything. But if I restarted this routine, then it was like, no, the records are still there. So somehow, internally it's doing the delete in memory and only puts it physically to the database file when you push commit. That's quite typical that happens, but it was misleading. So, okay, we forget about that for now. Then I just added the measurement capture logic. So it's basically the same thing. We take the JSON data and we process the experiments and we put it into a pandas. So we can do the graphs, and then we insert the data, the measurement entry into the database. It's using SQL insert with the create. I think we can go look at that. So this is called, so then it uses this insert SQL command and puts the data in the database. So it uses the database connection and the measurement to insert in the database. And again, I suffered from the fact that when you go look up data, even if you're looking at like educational data, very seldom do they say this applies to this specific version of a specific functionality. So it could have been useful if they'd written in some of the tutorials at the beginning, okay, that this is for SQLite, this version on Python 3, because then one would be able to like cross-check if one has the same version. Right. Moving on. Now I added some more experiment definitions to the UI. I wonder if I started it or am I running this or not? Let's see. Window again. Too many windows. That's why it's called Windows. Windows. Let's see now. Here. So now what I've done is this is probably not the most sane way to do it, but anyway, I added a button for each experiment with its configuration. So this could be automated. It doesn't have to be in this way. So, but I don't know. Somehow I just need to draw the line. Like, okay, we're gonna like have it this level of automation, and I mean, we want to move on with this experiment. So I don't know if I will automate the execution of all experiments at the same time. Anyway, let me know in the comments if somebody wants me to do it, and I'll do it. It's not that difficult. Anyway, you can see here what the effect of the heater should be, what is there, which of the fans is on, and how long will the time be allowed, or how long will the experiment be allowed to run. And then I was thinking I don't want to create hard-coded experiments on the Arduino side, because basically in this system to run an experiment is basically these parameters that one wants to control. So what I did is where is my Arduino? It's here. So what I did was that I created a command line format for it. So you can say over the serial line you can say execute, and then you give an experiment name. It's not actually used on the Arduino side for anything, but you can give it. And then you can have these switches, or they're basically hard-coded switches, where you define the effect level if the fan 1 is on or off, or fan 2 is on or off, and then the maximum execution time of the experiment, and then it uses a bit of parsing logic here. Doesn't seem to be any built-in function to parse the data from a string, but let's see if I can find it. Here, I copied with pride from this is actually the same piece of code is available from many different websites. I mean, it might not look exactly like this, but anyway, this is basically the same. Just it goes through and find it again. Let's see where it's being used here. So you say, okay, this is the string you want to parse. This is the delimiter you're using, and then this is the index of, like, because I'm using space as delimiter, like what index of the space does it. So I can say if I'm doing 0, then it will pick up this one. If I say 1, then it will take this one, and so on and so forth. So I parse them all out as strings, and then I do a string check and convert the fan state to booleans. And then basically I do the time conversion to int, and then I just say I created another overload of the execute statement where it takes the parameters from the command line as values, and then it runs a same overridden experiment in it to actually execute or to set up the experiment. So here we see that it uses the values. So it's really nothing mad. This I showed, this code I showed last time. The only one in the difference that I've added is the execution time is now controlled. So I take a snapshot of the millis value, and then in the main loop, set up and loop. So this is the same experimental loop, and then here it's just checking that, okay, when has the time been eaten up, and then when the time speeds up, then it says shut down, so then it stops the experiment. What I can do now is I was going to so I said there's nothing you can see in this experiment, but it's the same. This is the experiment setup. So. that's wrong. Okay, this way around. Anyway, we have the experiment. As I said, it's a pity I can't really see anything, but I'm going to start. Maybe we go to the desktop then. That's probably more visual on the desktop actually. Sorry about all the switching. I'm still not a very pro at switching between different views. Sorry, I'm finished off the food. Nice food. Need to go and get my son from a party, so I need to finish the food and finish this video and then pick him up. Well, work is never finished if you're a parent. First you do your normal 8 hours, and then you continue with other stuff. And then you produce videos. No idea how one has time. Anyway, I'm going to run the second test here, because I actually run through this first one. So I'm going to try and run the second one. And as you see here, it executes with this longer. Yeah, seems to have started. Not that it really shows anything much. You get one extra light on, I think. Yeah. Can actually show that. Let's see. Ridiculous, I know. Yeah. But anyway, if we go back to the desktop, so here, so then we can actually, can just see that it's picking up. Right, I'm going to check that because this is still under test. Yeah, you see now it's picked up this many values from the test that is running, and the power supply indicates that there's voltage, and the oscilloscope. I have the oscilloscope on telling me what the feed voltage is, just because there's a little bit of a discrepancy between what the power supply shows and what the actual feed voltage is, and I think that's because I'm using pulse width modulation through the MOSFET, and I think that creates disturbance for the power supply, and then the power supply, basically the current limitation logic and the voltage measurement doesn't really work 100%, but whatever. It's a cheap power supply from China, so you can't expect the stuff to be, the components probably aren't big enough to really handle keeping the load. But I have monitored it on the oscilloscope, and it's good enough for this, I think. And so anyway, but I mean the bottom line is that now what I can do is with this setup I can actually parameterize the control of the experiment. So okay, I got a lot of buttons here, but I could actually I don't need to, when I'm dealing with the Arduino, I can tell the Arduino, okay, what effect do I want, which fan do I want, how long should the experiment run, so that I don't need to change the code on the Arduino. I know this could probably be done more sane, like I could have a execute all function or something. It is just a hobby implementation, so I think it's good enough for now. I don't know how much I want to move to the next level on this project. Because basically when we run these experiments, then we have what I consider to be the basic data to both train a artificial intelligence model and also test it. the static plot. This I showed already in the previous video, but here we see the heater block ramping up. And the heater block uses a running average, so that's why it seems to start from, like, you know, the environmental temperature is about 25. So it takes a while for the running average of the temperature to grow up to the level. So I'm going to cut it off at the beginning because that's really no meaning. And we're going to get all these test profiles. So it's with, you know, the idea being the fan is all, you know, the fans are off, all the fans are on, and then they're switching, and then there are different effects. And I was thinking I've actually decided now to try for as I said, this is just to, like, play around with artificial intelligence models. Is that I want to basically use this as training data and then run some other cases, like maybe with 30% effect with one fan on, and then I want to basically ask the artificial intelligence model that when I feed it a random test case with, you know, randomly selected values, like then oh wait, sorry. I want the artificial intelligence model to tell me which fan is running and with what probability. So I thought that would be interesting, because the I don't know if we can. I don't want to juggle the box too much, but if we view again, it should be like, should automatically change. Yeah. And Google popped up with this idea of having a premiere of a video. But I've heard so many negative things about it that I don't think I'm going to do that. Theoretically, it would be like you, as a publisher of videos or a maker, you can post the video, and you can define when it's going to come online, and then you can be there with the video, and then you can basically have a discussion forum with the viewers at the same time the video's running. That's what I understand, but I've heard both from viewers and from makers that the system, the mechanism doesn't seem to be working very well. So anyway, add to the comments if you think that it would be something of interest. Running live sessions would be kind of cool. But I know it's difficult with people in different time zones and stuff. It's not necessarily that easy to set up. Okay, now is there anything? Okay, well the test will run now for... It should run for the designated 60 minutes, and then it should auto shut down. And I should just be able to... Yeah, I don't know. I want to run it from baseline cooled down, so it'll be an artificial waiting while the box cools down to ambient room temperature, and then I can execute the next one. But I can do one test a day, and that will be like, it'll be done in some days. Anyway, I need to play around with building the rest of the infrastructure so the test can run in parallel with that. Anyway, this isn't a job initiative, so this can take as long as it takes. Plot again. Oh, I think I showed this static plotting. Yeah, I did. So now it's been running now for 18 minutes. Here you see the temperature profile. So basically the idea is I want to run this until we theoretically get a bit more of a steady state situation. Theoretically speaking, well, no, maybe not theoretically, but practically speaking, the heater will equalize to a certain temperature, and then the box internal temperature will continue to rise until such a point as there's a balancing effect between the ambient air and the insides of the boxes. So then you could basically say you have a steady state situation. So I just want to run it until you get approximate steady state, and that's about 60 minutes. I mean, as I said, that this is just a hobby experiment. So, and when I do the validation cases for the artificial intelligence model, then I'll be running the same 60 minutes. So there shouldn't be any variance. And I'm quite happy with the temperature delta I'm getting from ambient. So basically, when this comes to the end, then it goes over 60 Celsius. So at least one can get rid of all sensor errors. I'm still very unhappy with the the behavior of the thermistor that's measuring the heater block, but I don't know. Maybe that's a good test for the artificial intelligence. You know, it will have to deal with a very illogical temperature measurement when it comes to the heater blocks, and I mean it should be able to even out that kind of. I mean that's what models are supposed to be useful for. That they're very good at handling basically non-linear cases of crap. So if you would try and make a conventional calculation model out of this, with based on erratic measurement data, then you should have a difficult time doing it. So we'll see if we have an easier time doing it with the AI. Well, so anything else that's come up? I don't think I have anything on my list. Well, I have some stuff coming from China. We'll have to wait. Or wait, we don't have to wait. No, I can just show at least, because oh, where did I put that? Maybe get pique your interest a bit. Let's see if I can find it. That's a really small thing. Okay, maybe we can switch to this one. I'll see how it shows it, because this is very small. So, well, it takes quite a good picture of it. We should have more light in this corner. Anyway, this here is a LoRa radio module. ESP32 with a OLED display embedded, and it has all connection, and it has I/O capabilities like digital and analog and crap like that. It also came with a nice antenna pack. I mean, I know there's lots of other people on the internet who made content about LoRa radios and LoRa radio handling, so I don't know if I'm going to be any specially. But my approach will be from the perspective that I'm not a radio guy. I've never been a radio guy, and never will be a radio guy. So basically, if I'm going to be giving a rather simplistic setup of this, and I'm just going to use it for the stuff that I want to use it for. So could probably actually add some links to the guy who's the most specialized on this on the internet. He's made the most videos on this, on LoRa radios, if you want to get an in-depth view. But I just want to plug I want to plug this thing in. Okay, why am I showing it? Yeah, I bought this from China. And I did the classical mistake. They had a picture where they had two of these units in the picture. And this is sadly very typical to when you're buying stuff from Chinese resellers. But then I was misled to believe that they are actually two units for the price. And so one feels a tiny bit cheated, because you could have bought from another vendor, you could have bought actually two of them for nearly the same price. So this is what a trick they do, that they and I don't know why they bother, because it just means that people aren't going to come back and buy more of the stuff from them. So yeah, whatever. It's not a huge sum. These LoRa radios, the prices have tanked. So basically, it's not really a cost issue to get a hold. Programming is also should have gotten much better than what it was, and building a Anyway, I was thinking of going through a little bit different, more simpler examples than the guy I usually follow, because I think he's extremely good at it, but his approach is rather advanced. So I was thinking I would just show how and if we can use LoRa modules to communicate between each other. And then I wanted to communicate with see if one can have a LoRa gateway on the Arduino, and then I want to test the LoRa gateway concept based on Raspberry Pi. So, well, I mean, this stuff coming from China takes a while to come, so we'll have to wait for parts. And then we have this experiment also, and probably have to set up another project. It won't be this. It won't be the temperature test project, because the amount of data you're allowed to transfer, or you can transfer using the LoRa modules, is very small. So it would be like a temperature measurement per hour or something. So you can't, you can't really. Where's this? Let's see here. Also, you won't be doing it even this fast every 10 seconds or something. So there's some interesting wireless limitations, and I don't know if it's hard coded into the module, because there are wavelength utilization rules that say you're only allowed to use a certain, even if you have a certain bandwidth, you're not allowed to use all of it all the time. So you get into these weird, like, okay, under a certain time period, you're only allowed to use the bandwidth you have available for a very small amount of time. And then if you use it more, then you're supposed to, like, take it away from. I don't know. It was pretty complicated, and I don't know if that's enforced in the silicon, because the Chinese, basically, they take these LoRa modules, which are patented technology built by only a few companies on the planet, or maybe even only one, and then they put it on these circuit boards with displays and stuff and sell them at mass. So it'll be a bit of testing to see if these rules are enforced in the module, or whether you actually have to make sure you're behaving in the software. Yeah, so that'll be for future. But as I said, I'll probably branch off another project. Let's see how much of this right now. As I said, I think this is starting to be enough for the data gathering part. So if anybody wants a copy of the source, I can probably fix it up on GitHub or something. I mean, it's not the most fantastic code, but and I've gone through most of the main solutions in the videos that I've made, so you can find this code online. As I said, again, coming back to the problem with Python is that, and example and tutorials, that it's annoying to the extent they go of not saying what version is of the module, and what Python version is the tutorial for. Because sometimes it's critical to know that, because they can be talking about features that only work from a specific version, or it could be that it's like describing an old version that's no longer supported. Because they also do that in the APIs. They depreciate stuff, especially going over the boundary from 2 to 3. That suddenly things that have existed disappear, and it makes it a bit of a maintenance nightmare. And yeah. I think when you're dealing with hardcore commercial development platforms, you don't have this instability. But on the other hand, it's what can one do? I use Python because it's, like you see, like we've gone through all this example. You can very easily make it do lots of things without actually having to buy lots of third-party modules. So, like doing this data, this pandas data management, plotting and stuff. Oh, winter, cold. Yeah, it was yesterday night. It was -5 Celsius, and it has been an extremely warm fall. Now I think the weather has decided to give up. And then, of course, when the weather gives up, then we get colds and crap coming in. So we'll see. But anyway, keep tuned for LoRa stuff and further developments on the temperature experiment. I will try and run through all these cases. There's really probably no point in making any videos about running these test cases. Nobody will want to watch them anyways. That's a half an hour on that test. Okay. Well, I'm going to shut it down. I'm just going to watch through the video, and if the audio stuff has been working, and I'll post it. It was a pity about the desktop stopping working. I mean, I fixed by reselecting which desktop to display. Why did it lose it? It's been working fine for ever. I don't get with XSplit that it's just you can't be 100% sure that it will keep the settings that you've set up, or that I mean, maybe I'm blaming XSplit for it, it's not its fault. Maybe it's Windows that, because I have been getting Windows updates and stuff, so maybe it's the Windows that screws it up. But still, you would wish that they would work hard on trying to make sure that when you've gone through the processes of setting up these different views, that the next time you come, okay, now I'm just going to make a video. And I mean, many people do videos for livelihood. I mean, I do it for a hobby, so what the heck, I don't get damaged if it doesn't work. I mean, I just sigh and fix it, and it's not time critical. But some people that make reviews and stuff, it's time critical, and or they're doing live streams, like, now it needs to work, and then suddenly it doesn't. It's like, oh, panic. Yeah. Anyway, it was hopefully a good video, a little bit informative. Check it in the comments if you want to have any more info about this. Current client Arduino setup. Otherwise, I will call it closed. Because now I'm just going to gather the data, and then the next step will be to play around with the TensorFlow setup. So, I'm signing out now.